Let's press that. So if you've been watching my previous videos and you joined the Kickstarter campaign to get yourself an X1 Pro laser welding machine, well then you should be receiving your laser now. And from those still sitting on the fence, I've had a lot of questions, a lot of naysayers. So how about we unbox this thing and see what it's realistically capable of? Alright, so let's have a look through the main box first. Now mine was actually opened by customs, I think. And it actually arrived in a big wooden crate, but I couldn't fit that in here. Alright, so straight off the bat, we've got an inspection report, apparently. I was a little bit too zealous with the knife, I think. And also contains the on-off keys. Apparently we've got a nice set of welding gloves. This will shield you from any radiation, but it's not going to protect you from the laser, I'll tell you that. And then it looks like we've got 2 pairs of glasses. And apparently dual protection, you can see it's OD6 and OD7. And inside it looks like we've got some care and maintenance. And these are the glasses themselves. And trying to look as close as I can, that does look like a CE mark, not a China export mark. I just washed my hands because I was actually doing a bit of blacksmithing work earlier. I still do quite a lot, but I just don't show it on these videos because no one's interested. I did film a couple, I might show that in the future. But anyway, back to lasers. In this box we have quartz laser lens protectors. See that these are actually a consumable. If you get some dust or something on there and the laser hits it, well it pretty much ruins them straight away. So you need to have really clean air and gas going in. And I believe that's what should be in here as well. More laser protectors. Right, so tucked away here in these tins, we have boxes of nozzles. So you can see we've got a cutting head here, different width gas envelopes for the welding wire. And we've got a couple of different size forks as well. I haven't quite gotten on well with the forks yet, but I guess we'll look into that later. And then we've got the focusing tube as well. That's what I'm calling it. That's so you can adjust the tip to the perfect focal length. So we've got 2 tins of those, that's great. And it's given us all the data so we can find the replacement parts if we need them. So now we're moving on to the main event, the laser. So we're starting to see some warning labels, that's good. We've still got the button here for switching modes. Maybe there's a little cap we can put over that, never mind. Right, let's have a look at the rest of it. Haha, right. So great to see that they've taken on board my advice. We've got some good labelling that shows us exactly what the dangers are. So pointing out that we must wear protective gloves so we're not affected by the radiation. They're claiming to be the global leader of air-cooled laser welding machines and state their laser diodes are by Coherent, which I'm guessing is a recognised laser diode manufacturer. And then on this side we've got further warning with some details of the laser output. So the beam will reach 800 watts maximum and the wavelength is 1080 and 650 nanometers. They're also telling us not to open it up, because if you do, that'll obviously void any warranty. There was also a power lead as well. Right, let's check out the next box. Right, it appears to be upside down. Ugh. And that there is your wire feed. Another pair of glasses apparently. Exactly the same. Brilliant. Loads of glasses. I think naturally you'll be wanting to show you all your mates this, so it's good that they've given you extra protection. So that's the wire feed nozzles and some spanners. Doesn't look like there's any design change on that so far. And the rest is cables. This is the safety ground. It does nothing for the welding, it's just for safety. What I will do with this though is link it to my door, which is actually the standard procedure in industry where they use these. If someone opens my door, it needs to cut the power to this laser, making it safe. And it should be really easy to set up. We'll do that in a minute. So after that, this is the cable that links the wire feed to the main machine. And then we've got this auxiliary cable, which I'm assuming is CNC compatibility, which we will be testing. Right then, let me show you what's in this next box. Right, so this is a proper laser welding hood. So again, it does have CE marking, and it says OD8+, 950 to 1100 nanometer wavelength. But something you'll also notice about that is that this is air-fed. What we have is something called a PAPR system, which stands for Powered Air Respirator. So in here, we've got a filter that has a CE mark and expiry date. It says A1 plus A2 and TH3P. After that, we actually do have a pre-filter and a gauze. So in that looks to be like a little wedge of carbon felt and then a stainless steel gauze to keep any larger particulates out. And this is really important especially when welding stainless steel, because you get hexavalent chromium oxides, which are very, very bad for you. And if I look closer at the battery, now I would actually be very tempted to get one of my power tool batteries and use one of these adapters, because with Milwaukee at least, with their fast charging, I can get this battery charged in about 20 minutes. So I don't know how long this will last, but I know with one of these, especially on my other respirators, I can go a full 10-hour day. Right, so lastly, something technically not related to any of this, I've got in this box here. Now this is actually a Rotary positioner, and this came courtesy of Viva. And what I'm going to do with it is add a little Arduino controller, maybe build a little frame for it, and that way I can weld pipe and other rounded objects really smoothly. Should be a decent upgrade from the Lazy Susan. So I believe that's a NEMA 24 motor. Also came with a bag of other chucks and a nice big chuck key. And I've also gone ahead and gotten a little digital display and a stepper motor driver. That should be a little fun additional project. Alright, so these laser welders are still going to set us back about $2,500. But if you would like to win one for just £5, then note that I've set up a competition for you to win one. So the competition is hosted by Raffle, which is a British company. That's the competition itself. It ends on the 31st of May. Raffle is approved by YouTube, and we've had lots of previous winners. I gave away lots of heated vests for free, but they haven't quite left any ratings. But if you scroll down, John Smith won the A3 battery. He was really happy. We've got Joshua, who won the Laser Pecker 4. He shows you a little video on him using it. We've got David, who won the 10-in-1 welder. He seems chuffed. And we've got Jason, who won the Creality Falcon 2 Pro 60-watt laser. So thank you for everyone who takes in part, because this helps my channel directly. And that way I can find other projects like this to test for you. I am not being paid by these people, so I can give my honest and real opinion. And so far so good, so let's do some real testing. So quickly looking on the back, we've got our first on-off switch. That's right, there is more than one. Then we've got our main power lead, which is 220 volts. And on the end of it, we've just got a domestic plug. And in the UK, they're fused to 13 amps. Then we've got the cable that goes back to the wire feed. And below that, I've put in a 6mm pneumatic line that goes to our gas supply. That leads to this big bottle right here, which contains nitrogen gas. And this stuff is far cheaper than all the other welding gases. So I've turned the machine on. I've now put a spool of 0.9mm stainless steel wire on. You can see there's a little indent there that matches with this spigot here. We can now lock that in position like so. I've opened up these rollers and thread the wire past the spools. These can now come down and lock in place. And then to thread the wire through, we just need to press this button here. If we press and hold and let go, it will continue. And then press once to stop. And if we want to, we can also back feed. Just note that it will put a lot of slack on the spool if you do. So I'll continue pushing this through until it reaches the nozzle. There we go. You can see the little laser light just there. What we want to do is have that wire come back so it's just reaching the tip of that laser. Just there. That's exactly how you want it set up. So before we turn these on properly, I'm going to take this old screen protector off. So then, the two switches are on at the front. Let me turn the main switch on at the back and we'll see what the menu's like. Right, so this is interesting. This is completely different to the original setup. We've got the three main uses categorized and split up. Let's start with welding. Alright, so this is very familiar. You've got the power, the swing frequency, they've labeled it now. So the laser itself is only 0.4mm thick. The swing width is how far it travels from side to side, and the frequency is how many times per second. Now up here, you can say it says sus. A lot of people commented that that looks suspicious. Apparently that's meant to stand for stainless steel. If we click that, you can see we've got a lot of different presets. Stainless steel, CS I think is carbon steel. Alright, so apparently SECC is zinc coated steel. So specifically for welding galv. Now if you're going to do that, you definitely wear a respirator because that's toxic. AL I guess stands for aluminium. UDT is user defined type. So I guess we can specify that for things like titanium. And you know what? I don't know what OTS is. Right, so down here we've got different buttons. We can choose between continuous or pulse settings. You can see the menu has changed slightly. So we've got on-off delays just here for doing the pulses. This is handy for super thin metalwork where you're really trying to control the heat. Then you've got this button for gas. Now that is a purging tool. The gas will automatically turn on and off as you're using it. But to test that there's gas, you have to click that button. Next you've got wire feed. That enables it to have wire or no wire depending on the operation. And what's really nice is this is all glowing green, whilst before it didn't do that, so I didn't know how to turn it on. Oh, look at this. So if we wanted to arm the laser, we now have warning labels. See, it says wear glasses and a respirator before starting the laser. That's brilliant. That's good that they're making note of that. Confirm on. See, now we're glowing green. Some people have said that should really be glowing red, so you're telling it's dangerous. But I'm quite happy with the green to know that it's on. After that, we've got the wire feed configuration, and it's different for pulse and continuous. This is the actual speed of your welding, because the wire is pushing you as you're going along, and the rest is to do with the wire pullback as you finish the weld, so it doesn't get stuck. We go on more. This gives us more settings to do with our gas shielding. That's always very important. Now we've got main settings. Monitoring system's very interesting. You can see it's telling us that we don't have enough gas pressure. It's because I've not turned it on yet. And we've not put in the safety ground either, so it won't start unless those are sorted. Also, if I hit the emergency stop button, you can see the e-stop is now activated. If I turn that off, I have to also click reset up here. There you go, it's turned green again. So if you're struggling to get yours started, just check on this panel first. You can also clear alarms here. Lots of safety features. If we go back on settings again, the other main thing to look at is the red light alignment. So depending on how you've configured your torch, it might not be dead centered. So I've brought it over to the right. Now you can see that laser is dead centered on that bit of wire now. So I will say this, I don't know if it's noticeable in the video, but the fan is definitely getting louder and louder. It's obviously using a lot of computing power, but never mind. Right, let's go on a different mode. Let's go on cutting. Oh, interesting, it's given us some details here on the cutting angle. Vertical cutting, it's saying, is strictly prohibited. Must be angled cutting. And I believe that's because of the reflective properties of your material could go back and damage the laser. So they've gone and mentioned this, probably to the advice of their manufacturer. So to make sure your unit's going to last as long as possible, try and have it on an angle. That's obviously a bit difficult when we're trying to do CNC cutting. We want that to always be straight down. So interestingly now we've got power, we've got frequency, but now we've got duty cycle. The frequency, which is a lot higher than it was before, is to do with the pulsation of the beam. And the duty cycle is how much of that is actually on or off. I don't know why that's useful for cutting, but I guess we'll find out. Right, back to mode selection, let's go on cleaning. So now it's very similar to the cutting phase, except now we can increase our beam width. And I like it that it's already set to 8mm, which is the widest beam that you can get. Obviously that's 8mm at the point of 0, as you can see, but the further we go away, you can see that beam widens. So lastly, I would say, get yourself a screen protector. I've actually put one already on my other one. Right, so I think it's time to start a project. And what better than to get this rotary positioner sorted? Or at least that's what I thought would be a good idea. I've just spent days, literally days, trying to figure out the electronics components to make this thing work. Just to find out later that you can buy a little device for about £10 off Amazon. So I wanted my little display to show the RPM and the direction of turning. And maybe even have like a dial indicator so I know exactly what degree angle the chuck is at any moment. Now I dabble in programming so I don't fully understand everything. And so I rely on AI a lot to do a lot of this stuff. Turns out AI hasn't got a clue how to do this and make it right. And it was a real nightmare to get this problem solved. So I started off using something like this. A lot of people will be familiar with this. It's called an Arduino Nano. And the issue that the Arduino Nano has is that when you write code, which is basically commands, each line has a command that it's giving to whatever you're powering, it's only reading and operating one line at a time. So whilst the chuck is operating, if I just turn it on for you, I was trying to get the Nano to do two things at once. It was programming the exact speed of the chuck and feeding back information to the screen, which then resulted in the chuck just kind of like jittering, like not moving at all, like Just turn this off again. Imagine if it was a person standing in the middle of like a burning building and it could only pick one thing to save: cat or kids, cat or kids, and basically you couldn't make a decision, so it just kind of like sat there vibrating. That's what this was doing. So to fix this, what I had to do is create two separate modes. A mode to set the RPM and direction. So you can see here I can switch between clockwise and counterclockwise, and then adding a button to change the RPM. And once that's set, we can then switch to running mode. And I can get it to be very precise. Although at certain RPMs it's a little bit loud. So if you're one of my programming friends, you'll probably be like, why didn't you ask us to help you, Josh? However, I've got this thing where I'd rather suffer painfully than ask anything of anyone to help me. I'm sure a few men can relate to that. Anyway, these are about 13 quid, it says. Put a link in the description if you're interested. What I've also done is taken my respirator apart, and this actually requires 16 volts. My little battery pack here outputs 12 volts. So what I'm going to do is introduce this little buck converter. This is perfect for turning the 12 volts into 16 volts. We've got a little adjustment screw there to change the voltage. And then I'll add a little 12 volt input to the side there, like that. So my input is bang on 12 volts. My output, if I put that there, 16.2. So I'll solder some wires onto that. And those wires will get soldered over onto this. Right, so let's just check that works. I guess that's a yes. There we are. And then that will basically just clip on there. Beautiful. So after a few more developments, I've finally wired up the harness for this thing. So for those that like to nerd out, I'm using an ESP32 board now. We've got a main switch coming in with 24 volt power. We've got a little buck converter that turns that into 5 volts to run the ESP32. And we've got some fancy momentary switches. And after a few tweaks with the program, I've got it working quite well. So now what I want to do is fabricate a little steel box for it to all sit in. So I'll quickly knock this up, and what I've done is flattened it into these kind of patterns. So let's set up the arc droid and cut it out of some stainless steel. So then with your laser, wiring it to CNC, you can see the external control cable comes out to 4 wires. Black, green, red, and what appears to be an earth cable, which is green and yellow. But essentially we're just using these 2 wires here, so the red and the green and yellow. Now coming back to the arc droid, we just need to plug those into the torch connection here. It doesn't matter the polarity, basically inside there's a relay switch. That shorts the connection between these 2 wires when we want to use the laser. And so if you're building your own CNC, all you've got to do is connect those 2 wires to your trigger relay. So when it comes to the business end, you want to create some sort of bracket to hold the torch onto the gantry. I've also included a hard stop specifically for the arc droid, because what it does is it wants to probe material. If you've got thin stuff like I do, then it kind of gets distorted. So I'm going to run a few test holes for the stainless steel, make sure I've got my settings just about right. And then we'll cut out the box and see how it comes together. So after running a couple of tests, we have some success. This hole here was cut, it's 750 millimeters per minute, and we used compressed air, and you can see we've got some very sooty marks on it. The next one here was cut at the same speed, but using pure nitrogen. But I wasn't using very high gas pressure. So I turned up the gas pressure to something like 90 psi, and we have a very, very clean cut, which measures exactly 10 millimeters, which is what I set it as. So then, let's cut out the final box. So I've loaded the DXF into Arc Droid, and as a reminder, I'm putting on my air-powered respirator now. We'll turn on the laser, start cutting. Well, that cut absolutely beautifully. Let me show you a close-up. So this steel is 1.5 millimeters thick, and there is a little bit of wobble, I guess. And that's mainly because the laser torch itself is quite heavy for the Arc Droid. The Arc Droid is designed to take lightweight little plasma torches. And on the back you can see there's a tiny bit of dross. I might be able to cure that with better settings, but for now, I think that's excellent. Right, these are done. However, I did something very stupid. I started welding it without actually testing the settings. And you can see that was way too hot, got too much penetration. So I found some scrap material, and that is now more of what I'm looking for. So I went ahead and cut some more material out. Let me show you my settings. 50% power, swing frequency 30 Hz, the weld width 2.2 millimeters. If we enable wire feed, we've got 14 millimeters per second wire feed speed, and we're using a 1 millimeter wire. So at this stage I'm not worried about cross-contamination or purging the rear side of the weld, because it's not structural, it's not pharmaceutical, and it's not for eating off, so it's really just an aesthetic weld really. Otherwise, in an ideal world, all of this needs to be stainless with the clamps and everything, and the rear side of the weld should be shielded with gas. There we are, I think we're ready. Got a little bit sticky just here, but that is what I'm looking for. So the speed of those welds is amazing. So here you are, raw, unfiltered. That's probably the best weld. Over here was a nice weld as well, but every so often you would just stall a little bit. You would have seen me just kind of like stuttering. That's because the wire feed was no longer pushing me along, instead I had to manually move along. Of course, anything manual is imperfect. I could only dream of making welds like that with my TIG welder. That though was a massive disappointment. I should be able to clean that out though, which I'll do now. And to clean it, I'm going to use some polycarbide. This is basically plastic with glass particulates mixed into it. Makes a really good surface finisher. There we are, looking pretty. Let's fit the electronics and see if we can attempt to do some pipe welding. Finally. I can honestly say that was probably one of the most frustrating projects I have ever done. Basically everything that could go wrong did go wrong. 40 RPM clockwise, let's press that. Going anti-clockwise. So it appears I've wired the stepper motor the wrong way around. But otherwise, everything's functioning perfectly. So you might be wondering, what exactly am I going to use this for? Well, if you've watched my diesel heater and gasification videos, what I plan to build are lots of different heat exchangers, which in a nutshell is like a water-cooled exhaust system. Anyway, I've got this bit of pipe. This is 48 millimeters with, I believe, a 3.2 millimeter wall thickness. So I'll expand the chuck into that. So let's see if it's running true. So I'm basically just looking at a light gap there and just making sure that that's equal as it's turning. That's pretty good. Right, so I think we'll do a test cut and then we'll re-weld it back on, see how we get on. Let's just check the speed. I reckon I should go slower than that. 5 RPM, try that. That sounds a bit better. Try that again, maybe slow it down a little bit more. Nope. Alright, so I'm adjusting the settings. I'm going to do another cut next to it, I think. Oh, there we go. So you can see that's the kind of cut we've got. It's held on just here because I wasn't holding it perfectly steady. But you can imagine with a fixed torch holder, we can solve that. So I'll quickly clean this up. So I've put a 1 millimeter gap, hopefully that gives good penetration. Now the key is to get the RPMs correct. That seems quite equally matched now, that's 5 RPM. I mean, in some places it works. And that's beautiful. Well, those results are looking very promising, but obviously I need to work on the settings and the cleanup a lot better. So using that on car exhaust, I think that will be a game changer. But I need to spend more time dialing this in. There's your close-up. So clearly as my very first attempt at doing this, I need a bit more practice and to refine those settings. And the proof of concept what I'm going to be using this for is definitely succeeded. So hopefully this video has given you all the information that you need. I have a ton of projects coming up that I specifically need this machine for. So if you'd like to see those, please consider subscribing. It is completely free, but it makes a world of difference to me. And maybe I can even persuade you to watch one of these videos. But if not, can I encourage you to get out there and learn some skills for yourself and to forge a life worth living. And I'll see you in the next episode, hopefully. See you later.